Hello everyone and welcome to another episode of 2D Prototyping in Unity. My name is Kasanas. In the last episode, we took care of our projectile. For the most part, the projectile is done. It shoots out of our cannon, it flies away, it leaves a smoke trail, and it explodes upon impact. It doesn't yet cause any damage to anything, and that's something we're going to take a look at in another few episodes when we take a look at obstacles and enemies. In today's episode, I think there's a few things I'd like to do. I'd like to take a look at the camera, first of all. There's a lot of different options for camera. Let's take a look at our camera right now. I'm just going to hit play right here. Where's my mouse? There it is. When I hit play, we can see that our guy moves around, but the camera stays stationary. There's a lot of different options for cameras. Let's say I decided I was going to have it so that when I ran off the screen, the camera switched then, or you can have a camera that moves along with the character. And I think we're going to go with the latter. I think we're going to do that. I think we're going to go with a camera that follows along with our character. All right. So in today's episode, we're going to take care of that. Let's get started. Okay. So having the camera follow the character is not very difficult at all. It's something we're going to do within code. And we're not even going to use another camera. We're going to use our existing scene camera right here, our main camera. We've only discussed the camera very, very briefly, and we'll discuss it right now and take a look at this camera itself, the one that comes free with every Unity package here, with every Unity scene. The camera itself, like every other game object, has a transform node, and that transform node allows us to manipulate the position, this rotation, and the scaling of the camera. And that's exactly what we're going to be using in order to make our camera follow along with our player. And we're going to do it all through code. The camera itself has a number of different things associated with it, and we're not going to go too much into this right now. We already took a look at the perspective, the projection, and you can obviously change that with the field of view, so you can make your camera angle wider, etc., etc. We have the background here. Anything that we're going to see outside of, let's see if I can go way back. Anything we're going to go see outside. Let's say I move my camera this far back right now, or I made increase. Let's actually just do it like that. Let's increase this and see what happens. Let's increase like that. Yeah, right down here in the game view. See what you can see here? You can see the blue. This background color, this blue background color, is going to be what you see behind your fields whenever you start actually playing the game, if you can see past your background. We, of course, want to set it up so we can't. All right, so we're going to leave this at 60. You can change this background color really easily by going in here and selecting color. Let's say I want it to be more along the same color lines as something in here. I could go in and kind of choose a color like that, and that's it. And you can see over here that it's actually worked out. It's up there. All right, it's actually changed already. And if I again move this, beep, you can see that I've kind of got this brownish color now. So you should really, if your camera is going to be able to see past your backgrounds, whether you're doing 2D or 3D, you should be making sure that this background color, if you don't have something else that's going to fill the sky or fill the area, make sure this background color really adds a nice kind of blur, like a blur between your background and what the people are going to see. If you don't, and you end up with like a hard edge like this, it's gonna really pop your players out of the experience. So you want to make sure that you are 60. You want to make sure that your players are seeing what they should be seeing, and they have the best experience they can. These field clipping planes, the clipping planes right here, the near and the far. Basically, well, let's see if I can see I'll go into 3D. The near and the far will show you, this is my far clipping plane over here, and my near clipping plane is very, very close to my camera. It's 0.01 away. The far clipping plane is 1000. If I actually change this, let's say I change this to like 100, watch what happens. Boop. You can see that my clipping plane changed. And right now, you can see I can no longer see the background on here. All right, see down in here, the background itself is no longer visible, and that's because it's outside of my clipping plane. So things that are outside of the far clipping plane or inside of the near clipping plane, according to the camera, are going to 500. Let's put it at 500 for now. Are going to be invisible, and that's plenty. I've got it set to 500. If you can't see your stuff for some reason, just change this value. I don't think I'm gonna have anything go past the background. I could probably set this to like 200 if I really wanted to, or even less. Like whatever, however far this. I think it's at 100 exactly. I could set it like that, and it wouldn't change anything at all. All right. So that is what your clipping planes are for. And we won't go into everything else right now. You guys can take a look at this. This is not actually a camera exercise. All we're really doing is trying to make our camera follow our player. Down here is something else that we're going to take a look at later on, the audio listener. And the audio listener, you always have one associated with your main camera. An audio listener, there's exactly one in any given scene. There's exactly one. And the audio listener, what it basically does is everything else might have an audio source. So I could have an audio source on my player. I could have an audio source on the rocket. And when I shot the rocket, it would make a burning noise, or if it hit something, it would explode. And all these things would have an audio source. And the audio listener listens, as it says, listens for the audio source. And if an audio source makes a noise, then the audio listener says, "Hey, I found something," and it plays that noise. Okay, that's kind of it in a nutshell. This thing here listens for sounds in your game and makes the sounds available to the game itself. Okay, lots of times the audio listener is located on the camera because there's always a camera in the scene. It doesn't have to be. You can really put it in its own object or anything else you wanted. But in our case, it's actually on. I'm going to leave it right there on the camera, and we're going to take a look at audio in a much later episode. All right, let's go back to 2D here and zoom in. So basically, what we want is we want our camera. Let's focus on it with F. We want our camera to follow along with our player. And the way I want it to work is I don't want it to follow exactly. I don't want it to be this harsh movement. So when the player switches directions, the camera switches directions really quickly or anything like that. I don't want that. I want it to be a nice, smooth motion. So that is our first stipulation, that the camera has a nice, smooth motion and it slowly follows the character. So it does. I don't want to instantaneously start moving. I want it to start moving. If the character starts moving, it'll start moving a moment afterwards, and if a character stops moving, it'll slow down to a stop. All right, that is part of animation arcs. All right, and that's very, very important. We want to make sure we still maintain our animation arcs. We don't want to have a completely hard camera. I don't like them anyway. Maybe you guys do, and I'm going to show you how to adjust it in case you do anyway. We're going to set up our code to be able to adjust it for that kind of thing. The other thing we don't want our camera to do, if our player runs and falls off the screen, we don't want that camera to follow along. We want the character to fall off the screen and die. All right, and we're going to take a look at that in the next episode too. If the character falls, I think anyway, maybe we'll move on to obstacles. I'm not sure yet. But anyway, when the character falls off the screen, we don't want the camera to follow along with them. We want the camera to only go to a certain distance and then stop moving. All right, so that is our two stipulations. The third one, of course, is that it's following the character. So with those three things in mind, let's take a look at the code. So we're only going to need actually one script to make this all work. So with your camera selected, what I want you guys to do is go to Add Components, boop, and I want you to say New Script. And of course, it's like everything else, it's going to be a C# script. All right, and let's call this camera. Make a small c. Camera follow 2D platformer. All right, we'll call it that, just so we know exactly what it is. And we can always take these scripts that we write and use them later on. So I'm giving it a name like this. So if later on I make another 2D platformer of some kind, I can say, oh, I've already got my script to make the camera follow it. All right, once that's done, I'm going to say create an ad, and boop, it's going to show up right here. And I'm going to double click. And I'm going to open up MonoDevelop. Good, it opened up in the right spot. All right, perfect. This is our MonoDevelop. You guys have already seen this a billion times. What we're going to take a look at today is a simple, only one thing we're going to have to add in order for this to work. We're going to add actually a lie. Now that I think about it, we're going to have to add a few things. The first thing we're going to have to add in is our public variables. Just like we always do, I'm going to add them at the very, very top. So this is a public variable, and it's going to be a transform. And we discussed why in the previous episode, why I would want to use a transform as opposed to a game object. The transform itself, by looking at a transform rather than the game object, rather than the top layer, I can always go from the transform to its game object, but I can always go from the game object to the transform as well. But in this case here, I want my camera to be following, to have a match to the transform of my character. All right, if I go back to here for 1 second, and I look at my character, I want the camera to be in some way associated with this transform. So I might as well use that directly. So I'm going to have a public transform, and let's just call this target. All right, and this target is going to be what the camera is following. What camera is following? All right, that is going to be what the camera is following. We're going to need one more public float. We're going to need another public variable, a float, and let's call this smoothing. All right, and the smoothing is going to be the dampening effect that occurs on the camera. So how quickly the camera starts to follow and how quickly the camera eases off in its following. All right, so we're going to need a couple more things. So we're going to need a few. So this is just the dampening effect. Oops, effect. All right, we're going to need a couple of other variables in here. We're going to need a private, because we don't need this to be available in our inspector. A vector 3. We're going to make it a vector 3. Again, it's going to be associated with the transform. And let's call this the offset. And this value here is going to be the difference between the character right here and the camera itself. So we want to make sure that this camera stays a certain distance away from this character so that we always maintain a certain look to the game, and that offset is going to be what that is. All right. The last thing we want to put in is I want to add in another float, and it's going to be a private as well, and it's going to be called low y. And this is going to be the lowest point that our camera can go. So it's not going to be able to go past the low y, meaning when the character falls off the screen, the camera won't follow. All right. So let's go on back to it now and finish up. So that's all we really need as far as our declaration of variables are concerned. What I'd like to do is initiate them now, and we're going to do that right here in the start. You can do it in the start or the awake. It doesn't really matter. The first thing we're going to do is we're going to calculate and figure out what our initial offset is. So our offset is going to be equal to the transform, and when I say transform like that, dot position, it's going to position. It's going to be taking a look at the position of the camera currently. So I really want to make sure that my camera is in the spot that I like it to start off with. So the current position of the camera, and it's going to subtract from that the target transform. All right. Not transform. What am I saying? Target position, because we're already looking at a transform. If instead of using a transform here, we'd use game object, it'd be target.transform.position. But because we're using transform, it's just target position. All right. So what we're doing is we're saying, what's the difference between these two, and maintain that in this value of offset. And that's the one that we're going to maintain throughout the entire game. As well, we're gonna calculate our low y, and our low y is going to be the current position of the camera. So what I want to do, position.y. What you want to do is you want to make sure that your camera is in the position that you kind of like it. So I like the way this view in my game looks. I like the way the view looks. So therefore my camera's in the right spot. If for some reason I say, you know what, I don't like it. It's currently zeroed out. If I don't like it, I say, I want it a little lower or a little higher. I'm going to put it in the place that I want it to begin with, or left or right, however you want to do it. It doesn't really matter. But make sure the camera is in the position you like it, because your initial settings are going to determine how your game looks. That's how we're setting up this thing to work. So that's that. All right, only a few more lines here. What we're going to do is in the fixed update, and again, it probably doesn't matter if it's fixed update or update. We're going to put it in the fixed update because our character is moving as a physics object, and therefore it's being moved during the fixed update. So we might as well put the camera in there as well. What we're going to do is we're going to add in here. We're going to add in here an aim position based on the offset. So basically, what we're looking for is we're looking for where the aim position is where the camera wants to be. Okay, where does this camera ultimately want to be? So that is our vector. We're going to declare a vector 3, and it's going to be equal to a new. This is sorry, not equal. I'm lying. Sorry, I'm declaring a new vector 3 here. I shouldn't do this so early in the morning. Target cam pose is the new variable we're creating, and it's going to maintain the target position. So the current target, our current target position, target dot position, and it's going to be plus the offset. All right, and this is going to give us where the camera wants to be located. The camera always wants to be located at the target position plus the offset. That's going to give us that difference that we initially had. All right, great. That's the first thing we needed. The next thing we need is we need the ability to slowly transform into that position. So we're going to be moving the camera based on its transform. Transform dot position. We're not going to worry about rotation in any way because we're not rotating the camera in any way. Is going to be equal to vector 3. Because again, it's a 3D, it's a three-dimensional vector, x, y, and z, although we're ignoring the z. Vector 3 dot lerp. Now this is a new function. Lerp is basically going to allow us to move from one position to the next in a very smooth motion. So as it gets closer and closer and closer to the position that it's trying to attain, the target cam position. As our transform gets closer and closer to that position, lerp will slow down, and it's going to be slowing down based on the smoothing that we've included here. So this takes a number of variables. So where is it moving from? Well, it's moving from our target. Sorry, not our target. Our transform. Transform dot position. So we're going from our current position to, the next variable is the 2, and we're trying to get to target cam pose. All right, we're trying to go from this position to this position, and we're going to be doing it at the speed of smoothing. All right, which we've declared right here, smoothing. All right, perfect. Smoothing times time dot delta time. Now I think that's new as well. I don't think you guys have seen that yet. Time.deltatime basically says it breaks up so it's the difference in the time since the last frame. All right, that's what this gives you. If ever you say, I don't know what this means, this is a little trick. You can always highlight like this. You can hold the control button and the apostrophe button, and it's automatically going to launch for you. And you guys can't see it right now, but it automatically launched for me. Well, I can't show you that because it has my name on it. It automatically launches for you the help. Let me just shut some of this stuff down so you guys can see it. That way you won't be seeing my Facebook and everything else. All right, it automatically launches for you a browser, and it's going to automatically take you to the help menus. All right, so again, that was control apostrophe, and if you want, then you just click on this, boop, and it says time.deltatime. It's a public static, whatever, and it basically tells you how to use it right down here, and it tells you what it is. All right, the time in seconds it took to complete the last frame. All right, bam, let's get rid of that. All right, so basically what this does is if I didn't have this time.deltatime in here, what would happen is it would move very quickly. It would just go bam, bam, bam at our smoothing rate, and we don't want it to. We want it to move slowly to the new position in increments based on this smoothing. All right, and that's what this basically does. You guys can try it if you want to see what happens if you don't use time.deltatime. Take this line out for now, take this multiplication out, and try it, and you're going to see the difference in the two. All right, there's only one more line that we're going to need here, and that is our line to prevent our camera from following our falling character. All right, if our transform dot position dot y is lower than our declared low y value, which we declared right here, our low y value, then we want to make sure that it actually goes back to where it was. So the transform dot position, oops, I didn't mean to put parent, position, how do you spell position? Is that right? Yeah, that's right. Dot position is going to equal to a new vector 3, like we're always using, because again, it's our transform, and it's going to be the transform dot position. So we're basically still saying, I don't care about the x and y, position dot x, I don't care about the x and z, I only care about the y. And this is going to be low y, and this last, not low y, just low y. The last one is little t transform dot position. Oh, I hate it when it does that. Just give me my little t. Please don't autocomplete. Transform. I hate you. Dot. I'm going to change this to little t. This makes me so mad sometimes. Guys, don't autocorrect for me. Transform dot position dot z or z. We don't care. So basically, let's see what this does one last time. So basically we're saying here, if our transform position y is going below our low value, then we want it to pop back up. So transform position y is going to automatically be still following the z, still following the x, still following the z, but it's automatically going to be set back to the low y. All right, and let's save this off. File, save. Now, if everything is done right, let's see. I don't see any issues in my console. Perfect. Let's go back and take a look at our main camera. If we see down here, we've actually got a couple of different things in here now. Our 2D platform camera follow script now has a variable location for our target, and our target is, of course, the transform of the character. So I can take this and I can drop it in there. The smoothing value can be any number you want. So let's put in there 5 for now. If you put smoothing at 0, it's going to be moving very, very quickly, and we'll take a look at the two different things. But if I put it at 5, let's say, and I say start, and I've got maximize and play on. Now, watch what happens. See my camera? See my camera following my character along? Boop, boop. It is moving up and down, so if I jump here, you can see the top of our thing. And you can see that kind of smoothing effect. It's not a harsh difference. And of course, if I jump off, my camera is not following. All right, the camera did not follow my character to his death. And you can change this to any value you want. Let's say I put it at 0. Let's see what happens. I don't know what's going to happen, to be honest. If I put it at 0, it doesn't follow at all because we're multiplying by 0. If we put this at 100, and we try that out, bam, now we're moving very quickly, all right? Very, very quickly. You can see that. A slight difference here. We're still getting some smoothing in there, and it's not terrible. It's not terrible, but it's not as smooth. It's a little bit more harsh, all right? So you want some value in here. You guys play with that number and see which one you like. I'm going to leave it at 5 for now, and that's perfectly fine. Alrighty, everyone. I think that is going to take us to the end of this episode. That's what I really wanted to do. I wanted to make sure our camera was moving. It is. I'm going to do a little bit of cleanup here and move my camera follow script into my scripting directory, and that is now done. Guys, I hope you liked that episode. If you did, let me know with a thumbs up or a thumbs down if you didn't. I don't care. Give me a thumbs down. Tell me what I did wrong, however. Just don't say, oh, you suck. I want to know what I did wrong. And that way, guys, I can improve for you. I am making these videos not for me. I already know how to do this. These videos are for you. So if I'm not doing it right, if I'm not telling you what you need to know, then you have to let me know. That's important. Feedback to your teacher is very important. All right, guys, these videos are about us and not about me. All right, so thumbs up or thumbs down, perfectly fine. If you've got a comment, let me know down below. And if you haven't done so, please take a few seconds to subscribe. Have yourselves a wonderful day, everyone.